Voting Theory Class 10 Video 3. In this video we're going to talk about the final fairness principle which I want to talk about, and this one's called the independence of irrelevant alternatives. This one I think is the hardest and most complex fairness principle to get your head around. So let's give it a try. The definition is as follows. A voting system has the independence of irrelevant alternatives, but that's a lot to write, so usually you just say IIA. A voting system has IIA if the social preference between any two alternatives depends only on the voter's personal preferences for those two alternatives. So the question of who comes higher in the social preference, A or B, should only depend on how the voters feel about A and B. It shouldn't depend on how the voters feel about C and D and E and F and everyone else, because they're irrelevant alternatives. Right? The social ranking for A and B should only depend on how the voters feel about A and B. It shouldn't depend on how the voters feel about all the other alternatives as well. This is the independence of irrelevant alternatives. So another way of saying this more formally would be something like, if every voter's relative preference for A and B remains unchanged, but perhaps they change their preference order for the other alternatives. So now they think C is better than D, whereas before they thought D was better than C, or something like this. But their relative preference for A and B remains unchanged, then the societal preference for A and B should also remain unchanged. Okay? There's a story which is often told, and it somewhat captures the essence of IIA, and it goes something like this. So you're having a meal and you're going to order dessert, and the waiter comes and tells you that there are 3 different desserts for you to choose. There's ice cream, a cake, and some fruit. Okay? And you tell the waiter that you want the ice cream. And then the waiter informs you, oh, but the fruit is actually quite good. So then you say, oh, okay, in that case I'll have the cake. And this sort of highlights this issue because the fact that the fruit is good shouldn't have influenced how you relatively feel about ice cream and cake. Like, the fact that the fruit is good shouldn't have made you change your mind from ice cream to cake. And that's what this is trying to capture. Like, you don't want irrelevant information affecting the ranking of the alternatives. So this again is a highly desirable fairness principle for your voting system to have, but it's an extremely difficult fairness principle to satisfy. Okay, like none of the voting systems that we've spoke about so far satisfy this, apart from the dictatorship. All of the other ones, plurality, 2-round runoff, instant runoff, agenda, Baldwin, border, they all do not satisfy IIA. It's incredibly difficult to satisfy IIA. So let's look at an example of a voting system not satisfying IIA. Okay, and it's non-trivial just to even work out these examples. Okay, so the voting system is the border, and I've got 2 voting profiles right here. I'm going to work out the social ranking for the first voting profile. So in the border, remember, there are points, and you assign points like this. Okay, so this means that A is going to get 3 times 3 plus 2 times 2 plus 1 2 times 1, which is 9 plus 4 plus 1, which is 9 plus 4 plus 2, which is 15. B is going to get 2 times 3 plus 3 times 2 plus 2 times 1, which is 6 plus 6 plus 2, which is 14. C is going to get 2 times 3 plus 2 times 2 plus 3 times 1, which is 6 plus 4 plus 3, which is 13. And finally, D is going to get 0. D gets nothing at all. So the social ranking is A, B, C, D, like this. Okay. Now let's work out the social ranking for this second one. Okay, so it's a very similar voting profile. Not much has changed at all. I mean, if you think about it, the only change is these two have swapped places right here, and there's some of these letters have swapped places as well. That's the only change. Okay, so in this case, A is going to get 3 times 3 plus 2 times 1, which is 11. B is going to get 2 times 3 plus 3 times 2, and that's it. So that's 6 plus 6 is 12. C is going to get 2 times 3 plus 2 times 2 plus 3 times 1. That's 6 plus 4 plus 3 is 13. And finally D is going to get 2 times 2 plus 2 times 1, which is 4 plus 2, which is 6. So the social ranking is C, B, A, D. Okay? So why did I do all of this work? Well, this can be used to show that the border voting system does not satisfy IIA. And how can we see that? Well, we can see that the individual voters' preferences for A and B remain unchanged. So let me write this down. So the voter preferences for A and B are unchanged. Okay. So, for example, these 3 voters think A is better than B, and these 3 voters think A is better than B. These 2 voters think B is better than A, and they still think B is better than A. I mean, now they think A is worse, but relatively, if we just consider A and B, they still think B is better than A. Okay? And finally, these 2 voters think A is better than B, and they still think A is better than B. So all of the voters, their relative preference for A and B is unchanged. But the societal preference for A and B has swapped. Okay? But the social preference for A and B changes. From A better than B to B better than A. So what does this mean? So the border does not satisfy. IIA. Because the social preference for A and B depends on more than just the voters' preferences for A and B. Okay? The voters' preferences for A and B were unchanged, but the societal preference, the social preference, has changed. So the border voting system does not satisfy IIA. Okay? That's the end of this example, and that's the end of this video.